So I already introduced the physics. What the physics is, what is the contribution of physics in your day-to-day life, how it contributes in innovations, experiments, and so on. Now the first chapter in class 9th, the name of the chapter is motion. Whenever a word comes in front of us, it appears in front of us, it visualizes, it start picturizing in the mind, it is something talking about the movement of the object, movement of the object. Here, my children, as it is said that, as I have given you the definition of physics, is a branch of a science which deals with the natural phenomena. So, why these two words? Here I have written the rest and the motion. These two are the opposite word, rest and the motion. So motion, something it is movement. Rest, object will not move. Dear children, here one thing is very, very important. Whenever we say that something is in the motion, you have a lot of examples if it would be asked you, and if you will read NCERT, it's given a lot of examples. But this motion, how will it deal with the nature? So one question it is given here about this, probably the changing of the season, sunrise, the phenomena of sunrise and sunset. There is some reason, there is some logic behind the motion. So let me define first about the motion. If normally if you go to define the motion, simply it is said that if motion, to change the position, with respect to time. Something it is, we know something is in the motion. How we will define it, how we will express it, how we say in the language of physics to change the position with respect to time. This is called object has a motion. Rest, yes, opposite of this, as I said, this is the word opposite of this. But dear children, what is here, you need to explain and you need to understand. It's very easy to give the example, something is in the motion and something is in the rest. If question comes in front of you, I am asking you, suppose you are traveling in a bus, you are sitting in a bus. If anybody will ask for whether you are rest in the motion, so this question becomes complex. Bus is in the motion, you are in the rest. And yes, because you are in the bus is in the motion, so you are also in the motion. So the answer for this question is not as straight. Here, you need to think, you need to explore, you need to answer in a smart way. Again, I am just putting a same question in front of you. Suppose you are traveling in a train and train is in the motion. Train is traveling with the speed of 50 km per hour. If anybody put a question in front of you, you are sitting on the berth in a train. If anybody will ask for, my dear, whether you are in the rest or you are in the motion. So, the both answer is possible. You are also in the rest, you are also in the motion. So, understanding this rest and motion, we need, that is a very popular word and it is given in your NCERT also. If you will read, you will understand. That is called frame of reference. Frame of reference. It is frame of reference. Frame of reference. Very good example, just I want to tell you. Suppose, as we all know, Earth revolves around the sun and we all are on the earth. And suppose someone is sitting, someone is not changing his position. If anybody will ask for the same thing that I tried to give you example, you are moving in the bus, you are moving in the train. And one thing more, if you will read NCERT very carefully, it is given all the motion we cannot, like if a normal question it would be asked from anyone. Suppose a worker is working on the road and if you'll ask, I am standing here, will you tell me whether I am in the rest or I am in the motion? That worker will reply you, yes, you are in the rest, you are standing, you are not changing your position. And as it gives in the definition of physics also, but you need to understand, earth revolves. we are on the earth. If we will go to sea with respect of earth, yes, we are not in the rest. Nothing is in the rest. Everything is in the motion because earth revolves. Earth is in the motion. So you need to understand this frame of reference. Whenever we define this word rest and motion, we say with respect to. With respect to. Suppose, now again I am just putting the same question. You are in the bus, you are sitting, bus is in the motion, you are in the rest. So you are in the rest with respect to bus. Here bus is the frame of reference. And bus is in the motion with respect to you, that you are in the reference. So that's why whenever we define something in physics, as I said you, it deals with the nature. It's a very wonderful thing. It's very beautiful thing. So you need to understand the word. So this is something about the rest and the motion. And here, whenever we talk about changing the position of the object, till now we have not explored with any physical quantities. Now it comes the physical quantities. There is the involvement of the physical quantities that I said you earlier. The very first physical quantity, it comes distance. Whenever it is said that, let me start with this, my dear children. Whenever we talk about the motion, it's not first time it is coming in front of you. You all would have studied about the different type of motion, various type of motion, rotational motion, straight line motion, circular motion, and so and so. Here you all will study about the straight line motion. Motion in a straight line. Let me tell in a very simple way. Traveling the bus, traveling the car, traveling the train, we all are walking on the road. These all are the example of straight lines. So here you all are going to study about the straight line motion. Motion which is on straight line. That is called a straight line motion. So the very first word, it comes distance. And whenever we define physical quantities, we'll have a trend. Like someone is telling you, introduce yourself. Would you say, what do you do? How you introduce yourself? You are saying your name, you're saying your father's name, you're saying your mother's name, you're saying in the name of institution, so on. So the same thing, whenever now we introduce the physical quantities, first we'll define it. Yes, because it is the physical quantities, distance is the physical quantities. Why distance? Distance, I don't understand. This distance is coming very first time in front of you. You would have heard many times about the distance, but yes, how we define it in the physics, this matters. So the length of path, the length of path covered by a body. The length of path covered by a body is called distance covered by a body. Distance covered by a body. So this, children, that I want to just, it's my intention to say you all, if any word it comes to you, you know, and if you don't have a way to express, you feel so embarrassed. Oh, I know, I could say, yes, but you should have some capability of something. So the length of path, you know, what the teacher would be looking for if the distance would be asked in the physics? The length of path. This is something, the length of path. Now, as I said, we are now going to deal with the physical quantity. So, it would have unit. So, SI unit we talk always. What is SI unit? Standard of International. So, the SI unit of distance is meter. SI unit is a meter. My dear children, I just want to relate this along with mathematics also, because it is the concept. If you won't have mathematical aptitude, you will have a great problem to understand the physics. So, length, distance, length. So, let me tell, wherever you are using unit meter, that is related to the length. Physics, it simplifies something. Like if you are talking, if I'm asking you, what is the area of the rectangle? You said that length into breadth. You said that meter into meter. Here length and breadth, both they are counted in terms of physics, only the length. That's it. So SI unit, that is Standard International, that is being used everywhere. So the standard, so SI unit is the meter. Whenever we talk about distance, in the context of internationally, we say meter. Although we have many more units for using the distance, kilometer, meter, centimeter. So you would go by this way. So meter, kilometer, centimeter, whatever you say, but the SI unit is simply a meter. Now, whenever it is said that now it's something more. We are just not making it complete. It is also a scalar quantity. It is a scalar quantity because direction is not specified with the distance. So this is something, whenever object it changes its position, the very first term it comes a distance. Now I'm just coming to the next point, that is here, if in distance there is a specification of the direction. If we say that your school is situated from your house in the south direction and of 5 kilometers. So we are talking about the distance, but here it is specified a direction. So we have another, that is called displacement. That is called displacement. Displacement is nothing. This is also a type of distance. When we have simply a magnitude, that is a distance, and along with the direction, that is called displacement. So this is the shortest distance. The shortest distance is called displacement. Shortest distance is called displacement. SI unit, it will have also a meter. And yes, which type of quantity this is? This is a vector quantity. So now whenever you are defining a physical quantity, please don't forget to write what it says SI unit, and don't forget to write which quantity it belongs for, whether it is scalar or whether it is vector. Now before going ahead, here this something, it is very, very important. We need to differentiate between the distance and displacement. So this is very, very important, how we differentiate distance and displacement. That you need to understand the difference between the distance and displacement. So yes, this is the first, you will define this, the length of path covered by a body, the shortest distance. What's the difference? Now distance will not be negative. Let me give examples. Suppose a straight line is this is A and this is B. Suppose object starts from A and the distance it is given, suppose 5 kilometers. So if object starts from A, it goes to B and again it comes A. So what would be the distance? The distance would be 10 kilometers. And what would be the displacement? Displacement would be 0. This is shortest distance. In the case of displacement, we need to see what is the shortest. Like I'm just giving you an example. Suppose this is A, this is B, this is C, this is D. If this something it is given, suppose this is given 5 meter, this is given 10 meter, this is given again 10 meter, this is given suppose 7 meter. If it is asking object starts from A and it is reaching at the A, what is the distance? So distance would be 5 plus 10, 15 plus 10, 25 plus 7, 32 meters. And what would be the displacement? Displacement, if it is reaching at A, displacement would be 0. If it is asking what is the distance from A to D, so the answer would be 5 plus 10, 15 plus 10, 25. And what would be the displacement from A to D? So this is 7 meter. So that you need to understand. So the magnitude of distance will be always, the magnitude of distance will never be negative, will never be 0, and the magnitude of displacement may be 0. But more one difference you could write, it is a scalar quantity, it is a vector quantity. So whenever the difference will come, you must understand and you can answer the question. So dear children, this I am trying to give you something. I just try to simplify the language so that you can understand. After knowing the distance and displacement, children, you will board on the boat. And I am telling you, if you will see this video very carefully, you'll be very, very enthusiastic to answer the question. Now the next is speed. Speed. The speed. If you think about the speed, we normally talk about kilometer per hour. So kilometer, which is for distance, and hour, which is for time. So, and for speed, you would have used it many times in mathematics also, I am very sure of. So speed is equals to distance upon time. Distance upon time. And I'm talking about the whenever now we talk about the context. So this is something, this is meter per second. And let me tell you, if the speed comes in front of you, if you could remember simply the distance upon time, and in physics, if it has been told you to express it, to define it, if you are writing distance divided by time is called speed, there is no problem at all, my dear children. You should have a knowledge, you should have expression, you must know how to express this, you must know how to write this. Concept is very, very important in physics. So distance divided by time is called speed. Now just you see what's the definition, it is given in a different book. But what is the theme, what is the origin of the concept? Distance divided by time is called speed. If you write in this way, there is no problem at all. You must know the mathematical formula, you must know the mathematical expression. Now what it would have SI unit? Meter per second. And yes, it is associated with the distance, so it is a scalar quantity. So I am not going to give you more details about the speed. Once you know the distance, you could jump on the speed. The same thing it is along with the velocity. For speed, and now the velocity we have, velocity. What the velocity is? This is displacement divided by time. So if you write displacement divided by time, although it is given in different way, displacement per unit time is called the velocity, displacement divided by time is called the, so this is something. And yes, what would be the SI unit? Yes, meter per second. It is the meter per second. It could be written in this way also, ms minus 1 meter per second. And so yes, it would be a vector quantity. So this is something about the speed, this is something about the velocity. Yes, one thing it is that you need to understand, that average speed. So for average speed, as it is written, I am giving you example to make you understand the average speed. Suppose you want to travel from Patna to Delhi, and suppose it is 500 kilometer, and it takes total 10 hours by train. So average speed will be what? So just let me tell you the formula of average speed. Average speed is equals to total distance upon total time. Total distance upon total time. So whatever the total distance and whatever the total time it is being taken by you, that divide 1 to 1, and if it would be asked you average speed, so this average speed is this is something what the total distance traveled by the object and what is the total time taken by the object. That is simply is the average speed. This is the type of speed. It would have meter per second. Yes, whatever you know about this, the same thing it would be. So this is something about the distance, displacement, speed, velocity. Now we'll give something in the next video.